Trust me. All right, so here's some kind of example of one of the two consecutive numbers thing.
Okay.
Might not go so well. Why am I saying that?
I don't know.
I'm saying that because I'm going to make this up, right?
Okay.
And I might not hit it. You know what I mean?
Yeah.
Okay, so.
Get one that you know how to do.
So, two consecutive numbers. Have a product of 56. You can see why this was boring. What are the numbers? No.
No. Wait, this is easy.
Oh yeah, we can eyeball the solution, right?
Oh,
Somebody have a, let me steal your
Wait, I
calculator
can do
for a
this
second.
without doing it.
Yeah, I know. So let me make one up that's better.
Why don't we just find one from the book?
Oops. Why don't we just make one up? Because that's what the book did. There you go. Oh, we can't eyeball it anymore. Thanks. All right, so how do I figure this out?
Factor it out. Factor true.
Oh, that is so cheating. You guys see that? That's a really cool number theory thing.
Is it cheating though?
Yes, it's totally cheating.
We couldn't do it on a test?
No, you can totally do that in a test. Go for it.
But that's cheating.
It's just not the technique I want to showcase. Why is it not the technique I want to showcase?
Because it's something childish, I'm assuming.
No, it's a great technique. It's really cool. But the technique I want to do is the one that the book uses, right?
Yeah.
Which is this thing about quadratics. So if I want to use a quadratic, I'm not going to factor tree it. You guys want to see them both? The factor tree thing's super cool.
I would love to.
Yeah,
see that.
thank you.
Okay, let's set up the quadratic first and then we'll play with the factor tree. I know, boring, it sucks. Okay, what do I mean two consecutive numbers? Number, right? And then what's the consecutive number after number? You guys see this? This is kind of the crucial fact here, that two consecutive numbers go like this. They go something and then something plus 1. So what variable do you want to use for something? Boring. Guys are boring. Okay, we'll use X. That's fine. Don't use C's. They get too easily confused with parentheses. Okay, so I got X and X plus 1. What does it mean for their product to be 462? Yeah, that means I take X, I multiply by X plus 1, I get 462. So I get out of this, yeah, make sure you remember to distribute, right? So I get X squared plus X is 462. Okay. Should we double down on this one and solve it by completing the square?
No.
Okay, so how do I solve this?
Trying to find the constant.
Okay, so there are a couple options, right? We could complete the square, or we could...
Subtract it from that side and make it 0, and then put negative 462.
Okay, we could move this to this side, and then what?
We should just gonna use the quadratic.
And then do the quadratic formula? Okay.
Yeah.
Why or why not would I... Why would I not like to complete the square on this example?
It's too hard.
No, completing the square is okay sometimes. On this one, it's a bad idea. Why?
They're both.
Why am I? Yeah, I'm pointing at the coefficient here, right? The coefficient here is 1. In completing the square, I have to divide that by 2, right? Is with me on that?
Yeah.
That's going to put a fraction in my brain, right?
No fraction.
I don't do good with fractions in my brain, yeah? So I maybe am not going to do that, right? Okay, so let's do the quadratic formula instead.
Yay.
So we take our x squared plus x, and then, what were you suggesting, CJ?
That x minus 462 equals 0.
Okay, so we need to move the 462 over, right? And then we can identify our A, B, and C. So what are our A, B, and C? So A is, B is, C is?
X squared A.
No.
One.
The coefficient on x squared is A, right? So the coefficient on x squared is 1. Coefficient on x is also 1, and the coefficient on, right, the constant, the thing that's left over, is negative 462. Oops, sloppy. Okay, so what do I do with this information?
Plug it into the quadratic.
Cram it into the quadratic formula. Okay, so the quadratic formula says if ax squared plus bx plus c is 0, that's the situation I'm in, right? Then x is negative, all right, what's b? 1 plus or minus the square root. 1 squared minus
4
Times
okay? That's going to be a big number, yeah? And then this is all over 2 times 1. Okay, so some of this I can simplify easily, right? Okay, so this is, let's see, negative 1 plus or minus, ooh, scariness, right? Okay, so there's 1 plus, right? 4 times 462. Okay, so get 4 times 462 out of somewhere. Where do you get that?
1,848.
Which is why you're gonna lose your calculators, right? Thank you.
What was it?
1,848.
Okay, you guys want to talk about calculators on your test for a second?
Yes.
You may use a calculator on your test. I do not care. It will not help you, but you can use it. I'm not putting numbers this big on your test. Okay. And then what am I supposed to do? All over 2, right? Okay, what else? Okay, so I get negative 1 plus or minus the square root of 1849 over 2. Does 1849 have a convenient square root? I don't know. How do you find out? Calculate. That's why God invented these things. Or Turing or whoever actually invented the calculator. 97?
It's 183.
What?
Is it 1849?
1849.
It is. It's 43.
Should be.
Yeah.
Yeah. So it should be because I made this, right?
Oh.
Remember, I didn't just guess. I was going to just guess, but then I decided not to. Okay, so I get negative 1 plus or minus, what was this? 43?
43.
Over 2. Okay, so what are my answers?
Don't you exclude the negatives?
Okay, so let me see. I've got
Negative 44 over 2, and then 42 over 2.
okay, so I get x is negative 44 over 2, or x is 42 over 2. Right?
So negative 22.
Okay. Right? All right, so what are my two consecutive numbers? Are these my two consecutive numbers? My two consecutive numbers are 21 and 22, or
Negative 21 and negative.
or negative 21 and negative 22. You guys see that? I didn't have a restriction about positive here. Your book usually phrases this a little differently, right? Problems in the book are usually phrased two positive consecutive integers or something. So my answers are the two consecutive numbers are 21 and 22, or negative 22 and negative 21. Right? Answer word problems with a sentence. Right? Cool? Questions, things?
Can we see the factor tree? Because I messed up on that.
Yeah, sure. The factor tree is a very cool method here. It does take a little creativity. You have to be a little bit clever with it, but it is there. So the factor tree method is you would take your 462 and start factoring. So 462 pretty clearly has a 2 in it, right? What's left if I divide by 2?
I divided by 4.
Is it divisible by 4?
Kind of. It ends up with
Kind of, no.
0.75.
So no, it's not a factor.
No.
So if I divide by 2, I get
231.
231.
But that's why I did it by 4. It's because it entered with 1. And I know that nothing would go in there. Maybe.
Yeah, 2 doesn't go in this. Why do I know 2 doesn't go in here?
So let's be off.
Because it's odd, right? Okay, so what does go in here? You guys know a trick? Do you know the trick about if you add all the digits together and it's divisible by 3, then the number is? That's a super cool trick. If I add these digits together, I get 6, right? 6 is divisible by 3, so I can take a 3 out. What am I left with when I take a 3 out?
77.
77. Okay, now what can I see about 77?
11 and then 7.
11 and a 7. Okay. So now I need to, this is factored now, right?
Yeah.
I know that 462, right, is 2 times 3, 2 times 3 times 7 times 11, right? And now I need to group these to make two consecutive numbers out of them, right? There's a really cool trick here that you know you have to group the middle two and the first one and the last one. Because they have to be consecutive numbers, right? So they have to be about the same size. I have 4 factors here. There's only 2 ways to make kind of the same size numbers. They're to multiply the medium ones together, to multiply the small one times the big one. Otherwise, you could try the combinations of these. Right? You could try grouping these in different ways and getting kind of different numbers and see what you get. So like one way we could group is 6 times 77, right? Those aren't consecutive, so that's not the answer. Another way I could group is I could group, let's see, 2 times 3 times 11 times 7. That's 7 and 66. Those also aren't consecutive. Another way I could group is 14 and 33. Right? Those also aren't consecutive. That's why this takes a little more creativity.
Yeah.
You guys see that? If I had more factors, Like if 462 had 10 factors, then this would get to be a nightmare. Because then I wouldn't be able to do the trick about eyeball the big one, the little one, and the two medium ones. That's totally out the window when there's 10 things. Cool. Good call though. Very cool trick. Questions on that? You guys okay with this technique? You all have heard and understood that there will be a solve the kind of quadratic-y thing on your test, right? Still taking a test where one of the chapters was about quadratics, right? Everybody knows how to complete the square?
No.
Okay, let's talk about completing the square.